Okay. So again, I folded it into thirds. So I'm going to turn it sideways so I can write on it for a second. I want to write on one of the outside flaps. Okay. So first of all, I want to tell you that this is lesson 4.4. So I'm going to write that 4.4 I can. And then you're going to fill out the rest of that, right? And I'll post it in a hot second. I'll post your I can statement. That's your 4.4 I can. The next thing that I want to do is I just want to remind you what the symbols are called. So I want to remind you what the symbols are called, and I want to remind you what you do with each one of them. Okay. So the first symbol that I'm going to talk about is this one right here. Can someone tell me what that symbol is? Yeah, this is less than. Less than. So that means that my line, for my linear inequality, my line is going to be what? Solid or dashed? Dashed line. And am I going to shade above or below? Below. Okay. What symbol do you want to do next? Greater than. Okay. So greater than looks like this. Greater than, going to have a solid or a dashed line. Shade above or below. So we got into a big discussion last period about how do we know less than or greater than? Because I know at one point in your life, you were taught to think of this as an alligator, and the alligator eats the bigger piece, and that's how you know which way it's shaped. However, the problem with that is it doesn't tell you what the symbol is, right? It doesn't help when you need to know the name of the symbol. So here's how I think about this. If you look at this symbol, you notice that the point is the smaller side. Do you see that this point is the smaller side? Does everybody see that that little point is the smaller side? And that comes first. It's smaller, so it means less than. When I look at the next symbol, this is the large side. This is the large side of the symbol. That means greater than. So you have either a small side or a large side of the symbol when you look at it from left to right. And that's how I kind of differentiate between those two. And I didn't realize that you guys were struggling with that until a student said to me, like, how do you know that? How do you know the difference? So that's the way I think about that. You do it with the L. So you make an L with your finger, and then you copy the symbol. So if I were to make an L with my finger, that looks like less than. That's another way to do that. I didn't ever think of that. Okay. Yeah, good job. That's awesome, actually. I'm going to steal that, Kanaya. Okay. What do you mean go off the point? You mean like you're going to go this direction or this direction? That helps when you're doing it on a number line. But when you think about a linear equation that has a slanted line, it's hard to differentiate the above or the below part. You have to know the name of the symbol. Does that make sense? But yes, that does work. That works when we're talking about just a number line. All right, what's the next symbol? What do you guys want to do next? Less than or equal to. So this is my small side. This is the small side. So that means it's going to be less than or equal to. Less than or equal to. I don't really like the way I wrote that. Less than. There was not really a space there. Or equal to. Less than or equal to. So what kind of line is that going to have? solid line. And am I going to shade above or below? Below. So we just have one more that we need to talk about, right? And that last one is greater than or equal to. So that symbol looks like this. Notice that the larger side comes first. That's how I know it's the greater than or equal to. So is my line going to be solid or dashed? Shade above or below? Okay. I'm going to come around and peek and make sure we all have that. You have your symbols on there. Come on. Leave it up there for a second. Very nice. Very nice. Very nice. Good job, Jordan. Okay. Then we're going to flip it over to the inside. We're going to flip it over to the inside. We have 3 problems that we're going to do. 3 problems that we're going to do. I don't know if we did the same. We did them out of order. Does that make sense? Yeah, this is the next one. Really. Thank you. Okay, so I'm going to flip this open. I think I did mine upside down, but maybe not. So I'm going to do this just like we did for our notes. Thank you so much, ma'am. Just like we did for our notes. I'm going to identify the slope. I'm going to identify the y-intercept. And then I'm going to use S or D for solid or dashed. And then A or B for above or below. So slope. What is the slope to the inequality y is greater than negative 2x plus 4? Awesome. What is my y-intercept? 4. This inequality greater than means that I'm going to have a solid or a dashed line. Dashed. This inequality greater than means I'm going to shade above or shade below. Above. Can you see that? Yes. Shade above. Okay. So B is where I begin on the y-axis. So I'm going to go to positive 4 on the y-axis. And I'm going to plot my point. And then my slope is negative 2. That means I have to go down 1, 2, and to the right 1. Down 1, 2, and to the right 1. Down 1, 2, and to the right 1. Now I'm going to make a dashed line. I'm going to connect these dots with a dashed line. Connecting them with a dashed line. Okay. Am I shading above or below? Above. Okay. How are we on that first one? Do we feel okay about it? Yeah. Yeah, it will. Okay. Does anyone need more time on that one? Okay. I know there's a whole bunch of A, B, C, D ordered pairs up top. We're going to go through those in a second. So let's go to the next one. I'm going to do the same thing. Slope, Garrett. Y is less than or equal to 1/2 x minus 1. What is my slope, Garrett? Just 1/2, right? X is not part of slope. Okay. Y-intercept. Angelina, what is the y-intercept? Did she say it? -1? Okay, perfect. I didn't hear. I'm sorry. Solid line or dashed line, Kanaya? Solid line. Shade above or below, Paula? Below. Okay. So I begin on my y-axis at -1. My slope is up 1 over 2, up 1 over 2, up 1 over 2. I can also go from the beginning, from where I began at -1, I can go down 1 and to the left 2, down 1 and to the left 2. I'm connecting all of my points with a solid line. And I'm going to shade where? Shade above or below? Shade below. I need to put the lid on my highlighter. It's drying out. Okay. Questions about that? We feel good about that one? Okay. My last one, my very last one, again, I'm going to ask for the slope and the y-intercept. So my inequality, y is less than -2/3 x minus 3. What is my slope? Yasmin, what's my slope? -2/3. Perfect. Rosa, what is my y-intercept? -3. My slope is -2/3 and my y-intercept is -3. Will, am I going to have a solid line or a dashed line? Dashed. Chris, am I going to shade above or below? Above or below? Look at the inequality. Less than. Shade above or below? Less. So I want to go below. Less than is below. Okay. So I'm going to begin at -3 on my y-axis. And then I have to go down 2 and to the right 1, 2, 3. And I can only do that one time. And I run out of space. So I'm going to go back to -3 on the y-axis, and I'm going to go up 2 and to the left 3, up 2 and to the left 3. Will said that we're going to have a dashed line. Chris said that we're going to shade below, shade below. So for this next part, I'm going to leave these kind of here for a second. I'm going to shrink it up so you can see them. For this next part, those are what your 3 graphs should look like. We have, I think there are 10 ordered pairs up top, 10 ordered pairs. We're going to try and determine if any of those ordered pairs fit into which one of these inequalities. They might not fit into any of them, and they might fit into all of them, right? Might fit into more than one. So point A is the ordered pair -5, -2. Which inequality has the shaded solution area? The last one, -5, -2. Right here is where point A would live. If you don't want to graph it on your paper and you just want to write it down below where it says solutions, you can do that as well. Okay. Point B, sir. They can. So point B, Will, fits the ordered pair 3, 0. Where do you see that fits? Yeah, the ordered pair 3, 0 right here, point B, but it also fits right here, point B. So I'm going to write it down below for both. B, the ordered pair 3, 0, B, the ordered pair 3, 0. Because it can go into both. What about the ordered pair 2, -1? 2, -1. C. Yeah, it only fits in the second one. 2, -1 is right here. That's point C. Okay. What about the point D? -4, -6. The last two. Let's see. D, -4, -1, 2, 3, 4, 5, 6. And -4, -6. Okay. What about point E? -3, 7. It's hard to determine, right? By looking at the picture. You think it might go in the first one? We think that it might go in the first one. How do I check? I could keep drawing a point, or I could take the point. So I'm going to show some work right down here. I can take point E, which is the ordered pair -3, 7, and I can plug it in to my inequality. Y is 7 is greater than -2 times 3 plus 4. 7 is greater than, that's a -3. What is -2 times -3? +6 plus 4. But what is 6 plus 4? Is 7 greater than 10? No. So where does E belong? It doesn't belong anywhere, right? So I wrote NS, not a solution. I'll put a little note up here. NS means that it's not a solution. So sometimes our graph doesn't show us all that we need to see to look at a point, right? So sometimes we might need to plug it into the inequality to check, just like we did for point E. We verified that, guess what? That didn't work. Okay, so that one was not a solution. What about point F, the ordered pair 2, 0? What about this? You think it goes in the first one? It's right on the line. Is that a solid line on the first one, or is it a dashed line? So it doesn't belong there, right? So F only belongs in the second one because that boundary line in the first one is not included. The boundary line in the first one is not included. What about point G, the ordered pair 5, 2? Yeah, 5, 2 only goes in the first one, point G. So point G, 5, 2. All right. What about point H? -1, +3. It's none. H doesn't belong anywhere. H is not a solution. Not a solution. So I mark that as NS. H is not a solution. It doesn't belong anywhere. Okay. What about the point -3, -1? What'd you get? Not a solution. Yeah. So point I is also not a solution. What about, can I ask you, Mackenzie, why isn't it a solution right here? Because that's the ordered pair -3, -1. Perfect. It's a dashed line, and that dashed boundary line is not included. What about the ordered pair -2, +5? Not a solution. Okay. What about the ordered pair 6, 0? Yeah, it goes in both. Point K and point K. So I'm going to write it down below. That point K belongs in both the first one, 60, and the second one. Okay. What about point L? -1,6. Not a solution. You're right. It's not a solution. And I'm going to go back to -1,6. It's right on the line, but it's a what kind of line? Dash. That's why it's not a solution. Okay. So I had period 1. We folded it back up and we put the glue on this part right here and we just glued it right in our journal. Okay. So we put the glue on